Okay, let's make sure I did my algebra correctly here. I took this term to the right side, so it became a positive 2 plus 7u du. And then I divided the equation by x bar, which brought x bar under the dx bar. And I divided by this parentheses over here. So I skipped a step or two algebraically, but it looks like it's going to work out okay here. Well then, what do we got? At this point, we are able to separate the variables, which you can always do with homogeneous coefficient equations. And at this point, we can integrate. So let me go ahead and erase the equation down here so we have room to work. They're both going to be logarithms, because like I said, the derivative of my denominator here is a multiple of this up there. And so, for example, here's what I'm going to do. When I take this derivative, I get minus 4 minus 14u. That's negative 2 times the top. So I put negative 2 here and 1 over negative 2. So I multiply by negative 2, I divide by negative 2 to keep everything balanced. The left side, I'm integrating dx bar over x bar. That's a logarithmic form. So I get natural log x bar, absolute value, equals the right side is negative 1/2 times the differential of 3 minus 4u minus 7u squared divided by that parentheses. So, the standard, earlier calculus way to do these equations is to do a u substitution, which is kind of funny because we already have u, so we'd have to use a different variable, wouldn't we? You can do that if you're more comfortable with that. I wanted you to see that this differential is negative 4 minus 14u, which is what I have up here, negative 4 minus 14u. And so I have the differential of this parentheses over the parentheses. Do you see that this is a dx over x form? It's a logarithmic form. In other words, I end up with minus 1/2 natural log, absolute value, 3 minus 4u minus 7u squared, plus a constant. I hope that little plus c is showing up on the camera screen there. I'm not sure if it got cut off or not, but there's a plus c over here. Okay, so there we have it. It's a mess. Let's multiply everything by 2. And the reason I want to do that is to get rid of this denominator. And so I've got 2 natural log x bar equals minus natural log absolute value 3 minus 4u minus 7u squared. And then when I multiply c by 2, I still get a constant. So still plus c. Now some other things we could do here. I'm after simplifying this as best I can. And I want to take advantage of the rules of logarithms to do so. So this 2 in front of the natural log x bar can go up here as an exponent. And then I'm going to add this to the right side. So I've got natural log absolute value x bar squared plus natural log absolute value 3 minus 4u, try to make that legible, minus 7u squared equals to a constant. Okay. Now I can add these logarithms together. The sum of 2 logarithms is the logarithm of a product. So we make some room up here. Here we are. We've got natural log x bar squared parentheses 3 minus 4u minus 7u squared. That was again by combining these logarithms into a single logarithm. It's a product. Equals to that constant on the right side. And now let's get rid of the logarithm by making both sides an exponent of e. And so now I've got x bar squared, and that always gets rid of the absolute value too. Also, 3 minus 4u minus 7u squared e to the c is still a constant. Now, what's left? We have to resubstitute back. To get back the original x and y, I've got to try to remember what u was, and u, I believe, was y bar over x bar. So I hope that's correct. I'm going to make that substitution back into here, and then we'll have to substitute these guys back in. So as you can see, it's a pretty messy, prolonged project here to solve all these linear problems. So I have x bar squared, parentheses, 3 minus 4 y bar over x bar, minus 7 y bar squared over x bar squared equals to constant. And this is kind of nice. When I multiply the x bar squared through here, it eliminates the fractions. So I got 3 x bar squared minus 4 x bar y bar minus 7 y bar squared equals to our constant c. And then finally we get to plug this stuff back into here, except we have to use x bar equal to x plus 26/25 and y bar equals to y minus 11/25. So I've got to turn these around in order to substitute for x bar and y bar. Alright, so one more erasing here.